Miss Lister here with our weekly science lesson. So as we have done for the previous 2 weeks, I would like you to complete the 3 lasts. I will read them to you and you are going to write your answers down. So, last lesson, which part of the eye allows light through it? Last term, name a nutrient that the body needs to survive. And last year, order these periods of time for the human life cycle. Start with which comes first and then which comes last. So you've got old age, infant, and puberty. So which one's first, which stage of development, so which one comes last? The answers will be on the next slide, ready for you to check your own work. So let's go through the answers together. So which part of the eye allows light through it? The answer there was the pupil, the small black dot in your eye, and it's actually controlled by the iris, which allows it to open and close when there is a lot of light or not enough light. Name a nutrient that the body needs to survive. So you could have chosen any of these: protein, fats, carbohydrates, vitamins, minerals, dairy. All of those are what we need to survive, and the small intestine absorbs those and sends them around the body. And last year, order these periods of time for the human life cycle. Start with which comes first and then which comes last. So it should have gone from the infant stage to puberty to old age. In this lesson, you are going to be recognising materials which reflect light. You're going to do a little bit of a practical investigation to explore which materials are the best for reflecting light and which are the worst, and thinking about the properties of those materials. On this page of the PowerPoint, you'll see some helpful hints about things that we will be doing and some tips that we need to walk away from this lesson with. There's also a list of things that you will need to support your household home learning. So the key learning, we know that we've been looking at that light travels in straight lines and can explain that how non-luminous objects are seen. Non-luminous there meaning not lit up. We know that all surfaces reflect some light, and that shiny surfaces reflect light better than matte surfaces. So matte surfaces are non-shiny surfaces. By the end of this lesson, you'll be able to record the results of reflection investigation in a Carroll diagram, and you'll be able to draw ray diagrams to show how non-luminous objects are seen directly and when they are seen reflected in a mirror. We have done ray diagrams. It is where the light source shines onto the object and then reflects that into your eye. You did those last week. Just on the opposite side of this page, you will see that there are a few things you need to gather. So now is the perfect time to do that. So if you want to grab yourself a torch and a few objects from around your home, you need to try and use lined paper. If you don't have any, please don't worry. A ruler and a pencil for recording. You could, if you wanted to, print slide 6 of this for a worksheet, okay? There are a few things that you might do to explore further. So you might like to research and explore mirrors. You could use a spoon, a mirror, or any toys with a reflective surface. And you might like to model how light reflects from a mirror using a football and chalk string in a paved area outside. So it's just how you could make a bigger light diagram using objects like a football, a mirror, and the chalk string in a paved area outside your house. If you don't have those, please don't worry. The last slide just mentioned Carroll diagrams. In case you didn't know what it was, I'm sure you'll have seen one of these before. This is just a simple Carroll diagram, and all it is for is sorting and organising objects and living things based on qualities and characteristics. Now, we did characteristics when we did living things, so you know that they're just the features of something. So in this one, we've got, is it a pet? Does it have legs? So if it's a pet and it has legs, it goes in that box. If it's a pet but it does not have legs, also fish, things like that, that goes into that box. And you can see quite clearly there how they've been organised. So we're just thinking what we already know about the reflection of light. So I want you to just jot down a list of the following and think about what they are made from. So think of 5 shiny objects, 5 matte objects, 5 luminous objects. So something that gives out light. And then I want you to just note down whether you think that this is a luminous object that gives out light, or it's just a good reflector and just reflects light. If you want any extra information, if you look down at the bottom, you could watch this link here that is linked to the BBC Bright Size website. Click on that for further information. In the lesson, you're going to be doing the practical investigation. So you're going to gather your objects. It could be spoons, it could be plastic items, all different things from around your house. Maybe gather around up to 10. And you're going to be deciding if you can investigate one of these questions. If smooth surfaces are always more reflective than rough ones, If white, pale surfaces are always more reflective than black or dark ones, if some surfaces reflect equally brightly when the torch is held at different angles to them or not. So if you choose one of those questions, you're going to investigate it and you're going to record your results on the Carroll diagram on the next slide. I've also put this onto a Word document so you can write on it or type onto it, but you will need to edit the titles to suit your question. This slide just explains to you how to edit your Carroll diagram in reflection of the question from the previous slide. So it says label your Carroll diagram to match the question you're investigating. So for example, if you're doing the smooth versus rough, then you're going to write whether it's reflective or not very reflective, or reflects better, reflects equally down the side, and across the top you'll write whether it's a smooth surface or a rough surface, and then you'll sort the objects into the according boxes once you have done your investigation. Here, this is just an extension of the work that you could do in regards to the reflection of light, and this work is about the reflection of light and mirrors. So you can explore reflection from non-flat mirrors using both sides of a spoon held at various distances. So you could have a look at whether a curved edge of a spoon makes a big difference to the reflection of the object there. So you could try to create an infinite tunnel using two parallel mirrors. How does it work? So trying to angle the mirrors very carefully together so it appears that they go on forever and ever. A little bit like those ones you can see at the fun fair sometimes where the hall of mirrors is everywhere. You might want to research what is special about the angles when you get reflection off of a mirror. So if you follow this little link here, there's a little game that you can play that will link to all of that for you. And there's a few other ideas that you can have a look there, and another clip all about reflection. If you were unsure of any of the terminology used in this lesson, please make sure you have a look at the glossary here. What I would like is that you make sure you use some of these in your descriptions of what you have seen. This is an opportunity for you to have a look at your Carroll diagram and your ray diagrams, the light showing diagrams, just to have a look at what your work could look like. This is a really, really good reference point for you to see how your work should look. And if you look carefully, the writing is neat. They've really drawn out their Carroll diagram, and it explores just a little bit further what your work could look like before you submit it to us. To finish your experiment, you should have a completed Carroll diagram. So make sure that you submit that to us to have a look, and make sure you write a little evaluation of your findings. Did you answer your key question? Did you find perhaps that smooth surfaces were a better reflector of light than rough? Did you find that paler surfaces were a better reflector, or the darker surfaces? Whatever you found, I would like you to write a couple of sentences just explaining what you found in answer to your question and upload it to us to have a look at. I hope you've enjoyed this lesson. Thank you very much.